4.2 exponential functions. An exponential function is going to be some sort of function with a variable in the exponent. So that's kind of what we're looking for there. So additional properties of exponent: for any real number a bigger than 0 and not equal to 1, the following statements are true. A to the x is a unique real number for all real numbers x. A to the b equals a to the c if and only if b equals c. That's going to be useful for solving equations. If a is greater than 1 and m is less than n, then a to the m is less than a to the n. So basically what that's saying is if your number, like your base number, like is 2 and it's bigger than 1, so like 2 to the x or 3 to the x or even 1.1 to the x, anything as long as that base number is bigger than 1, what they're saying is as x grows larger, the overall number grows larger. That's what that says. So it's talking about exponential growth, if you can remember back to that. So then the next one says if a is in between 0 and 1, that's what that says. If a is in between 0 and 1, so like 1/2 to the x or 0.4 to the x, if your base number is in between 0 and 1, then it's going to be decay. And so they're saying, as x grows larger and larger, then the overall number is going to grow smaller. And so they kind of reword it right here. You might take a second and read over that. Example 1, f of x equals 4 to the x. Find each of the following. So there are a couple of things you want to do with and without a calculator. F of -2 says plug in -2. So we have 4 to the -2nd power, and I want you to remember two things. So memorize this negative exponent is going to be a flip. And then, of course, we're going to do whatever this says. In this case, that's a square. So flip it and square it. So maybe you already knew that. That's going to be 1/4 squared. I flipped the 4 and squared it. Flip it and square it. That's going to be 1/16. So you should probably be prepared to do that problem without a calculator. Part B, we're looking at 4 to the 5th power. I'm going to use a calculator for that one. 4 caret 5, 1024. Of course, you can multiply that out if you want. 4 times 4 times 4 times 4 times 4. But when the numbers are extra big or kind of hard, I'd probably use a calculator. So 4 to the x, we're plugging in 2/3. So this one's probably the hardest one, because this is probably one you're going to need to know how to use without a calculator. So I suppose you could use a calculator. If you did, you'd have to put parentheses around the exponent, so make sure you do that. 4 to the 2/3 power is some weird, nasty decimal. And so if that's the case, you're probably going to have to do this one by hand. And so let's check it out. A lot of the times what we want to do is change our base 4 into a power of primes. So if you change 4 into 2 squared, you have 2 squared to the 2/3 power, which power of powers, we multiply the exponents and we'd have 2 to the 4/3 power. Now hopefully you remember that the 1/3 power is the cubed root. So I see the cubed root of 2 to the 4th power. Now, you could say that that's the same thing as the cubed root of 2 to the 4th power. Those are the same thing. And so you want to use whichever one you think is going to be easier for you to deal with. So I choose the first one. The cubed root of 2 to the 4th. Remember back to your algebra days, if you had like the cubed root of x to the 7th power, you were like, how many times did 3 go into 7? And it went in twice. So you said x squared with 1 left over inside the cubed root. It's basically division. 3 goes into 7 twice with 1 left over. So we're doing kind of the same thing here. 3 goes into 4 once. So one of the 2's comes out with 1 left over inside. Our answer appears to be 2 times the cubed root of 2. And so we can kind of check that out if we do 2 times 2. I like to do it to the 1/3 power. To the 1/3. I think that's the easiest way to enter a cube root. 2 times the cube root of 2. Same thing. Okay, so we're good. F of 2.15. So you have 4 to the 2.15. I think it's pretty obvious they expect you to use a calculator here. 4 to the 2.15. is a crazy decimal there. 19 point, what was it? 69831. 69831. Let's go ahead and do all of it. 061. Okay. So this next slide, they're kind of taking you through some basics of growth and decay. Notice when that A number is bigger than 1, it's going to be growth. And when that A number is in between 0 and 1, it's going to be decay. So you can read through there for some properties. This one's kind of important because it tells you what to plug in. Essentially, you're going to be making a table and you're going to be plugging some numbers in. So good numbers to try are -1, 0, and 1, but you might try others if it helps to draw the graph. And so then they're telling you if it's increasing, okay, this is growth and this is decay. And there's a horizontal asymptote at the x-axis, that is unless there's a shift going on. And then we're going to talk about the domain and the range. So the domain for either of these is all real numbers, and the range looks like it's from 0 to positive infinity.